The PT boats made by Elco, Higgins and others were lightning fast and all powered by Packard V-12 engines of similar types. Even before the renowned Plywood Derby nailed down the final boat designs, the engines had already been developed and were on order for the Navy. All PT boats used in World War II were powered by 3 of these beefy V-12 engines, about which there is a fair amount of misunderstanding. So let's take a look into what they were and were not. There's a common misconception that these were the Packard-built version of the Rolls-Royce Merlin aero engine known as the V-1650. This is incorrect. The Packard Merlin did not come online until 1941, and at that time all of them were pre-ordered for urgent aircraft production. Those surplus units were available until 1943. The other common misconception is that they were the earlier Packard Liberty L-12 engines, which is also incorrect. This error is reinforced by the existence of an inverted version of the Liberty engine being given the same V-1650 designation, though some years earlier. Let's first have a look at the Liberty L-12, since this is the grandfather of the PT boat engine. When war was declared on Germany in May 1917, there was an immediate need for aircraft and a robust, powerful, and lightweight engine to power them. The head of the Aircraft Production Board summoned 2 top designers, Jesse G. Vincent from Packard Motor Company and Albert J. Hall of the Hall-Scott Motor Company. They were invited to the Willard Hotel in Washington, D.C. and basically locked in there until they came up with a suitable design. The engine was needed for over a dozen projected aircraft, from the Airco DH-4 through to the XHB-1 heavy bomber. I guess they missed their family lives, because in just 5 days they had come up with the drawings for a 45-degree V-12 of 1,640 cubic inch displacement, or 27 liters, with overhead cams, 2 valves per cylinder, and liquid cooling. Packard built a prototype that ran well and made the projected 400 horsepower, and that was approved in August the same year. Come late fall, the War Department placed orders for 22,500 engines, now designated the L-12 or Liberty 12, with Packard, Buick, Ford, Lincoln, Cadillac, and Marmon. Hall-Scott themselves did not have the production capacity to get an order. Close to 20,000 engines had been delivered when the end of the war signaled the end of production, with Packard finishing engine number 6,500 on June 4, 1919. Although this engine had a displacement similar to the Merlin, the other similarities are quite minor. One major difference between the L-12 and the Merlin is that the cylinders on the Merlin are cast into upper and lower cylinder blocks, while the L-12 has 12 individual cylinders with integrated heads versus the Merlin's one-piece cylinder head castings. The L-12 has a 45-degree V-angle versus a more conventional 60 degrees in the Merlin. The next interwar iteration of this engine was extensively different. The 45-degree V-angle was widened to the more common and better balanced 60 degrees. Where the Liberty engine looks a bit like 6 Harleys strapped together, the new engine looks more like a modern automotive V-12. Stroke was reduced from 7 inches to 6.5 inches, while the bore was was increased from 5 inches to 6 3/8, resulting in a swept volume of 2,500 cubic inches. Do we start to see where the model numbers come from now? Where the L-12 had one-piece cylinders and heads, the new unit had forged steel cylinders with the combustion chamber integral with the cylinder, but used an aluminum valve cover and port unit that, like a cylinder head, had the intake and exhaust ports for the 4 valves, valve guides, water jackets, camshaft bearing pedestal, all integrated. All of this being bolted to the top of the closed cylinder. One advantage with this idea is that there's no cylinder head gasket to blow out or leak from exposure to combustion pressure or coolant. Remember that cylinder head gaskets weren't as reliable as in those days as they are now. With this change, all of the valve train was now enclosed. The bevel gears and the shaft drive for the camshafts were retained, but the points and coils ignition system the L-12 cams drove was ditched in favor of 2 magnetos and 12-cylinder distributors. Earlier units have the timing advance control slaved to the throttle lever, while later ones are fully manual. Lubrication is handled with a twin-circuit oil pump with a 3-gear rotor set to scavenge oil to the external oil tank and 2 to provide pressure to the bearings and feed oil squirters. The first generation 1A 2500 of 1924 produced around 600 horsepower. This engine was a commercial flop in comparison to the L-12, with only a few hundred being built. The unit was developed little by little, powering aircraft like the Martin T-3M and the Boeing TB. The final 5A 2500 of 1930 was supercharged and produced 1500 horsepower at the emergency power setting, which is pretty impressive for the time. Still, with the war over and aircraft design moving on, sales did not really take off, with total production numbers in the mere hundreds. For reference, the most popular version, the 3A with 800 horsepower, sold for about $20,000. During this time, the Army Air Corps had shown little interest in this engine or even the aircraft that it powered. So obviously when the Navy came along and asked for a Marine version, Packard were only too happy to step up. If you ever wondered why Liberty engines are to a penny and Packard 2500 series units are so scarce, now you know.
Monkeys have no tails in Zamboanga. Oh, the monkeys have no tails in Zamboanga.
Marinized version started with, you guessed it, the 1M2500. The 3M2500 was the model fitted to the early Elco 77-foot boats, later being updated to the 4 and 5M models, although not many 5M units entered service at the end of the war. As a marine unit, the exhaust manifolds must be water-cooled or risk melting at higher loads. These manifolds were welded fabrications and have a flange at both ends, one for the exhaust pipe to be fitted and the other to drain coolant from the manifold. They can be switched one way or the other, which is convenient and as it allows the exhaust to exit from either end of the engine. A 5-inch exhaust system was specified for each cylinder bank, and with those huge long drain pipes fitted to them, they make a most impressive row. Remember that in the 77-foot Elco boats, the 2 outer engines drive their propellers via a V-drive, while the center engine is mounted further forward and has direct drive. This is why all of the engines require a reverse gearbox. Most engines featured both a freshwater and raw water pump, although you could get them without the raw water pump if that was required. The crate engines from Packard would have the complete ignition system, carburetor, starter, generator, reverse gear unit, fuel pump, oil pumps, oil tank. None of them came with a heat exchanger for the cooling system or a fuel system, instrumentation, or much else. Despite the marine application, the M series carried on with its twin spark plugs per cylinder. All engines were supplied with 24-volt starter motors and DC generators with a very primitive voltage regulator set to output at 28 volts. The regulators being electromechanical, they have quite complex service needs and, like many of the other systems, require quite frequent tuning to get them to work correctly. Not only did output voltage have to be set on each unit, but all three in a PT boat need to be balanced. Now you throw in the fact that the regulators output will rise as the unit reaches working temperature, and you can see how a mechanic could be chasing his own tail around trying to do this. Now you can see from these pages in the service manual just how many tasks had to be performed at various intervals, from inspection to lubrication to replacement. Some of these tasks could be done in situ, and some required the engines to come out of the boat. These engines, being designed as aero engines from the outset, were built quite lightly. They are tested to be reliable with the scheme of maintenance that's shown in the manual, and are going to get fussy if fed with poor fuel or if the required service work is skipped. The guys you see here swapping engines are not doing that because the gym is locked. Like many aero engines, these have an overhaul life set at 750 hours. At that point, the entire unit is supposed to go back to a licensed reconditioning shop to be completely overhauled. The 4M engine still had a few variations between different models, like the cooling arrangements, spark advanced controls, but most importantly, with the later versions getting an improved centrifugal supercharger, which was more efficient and allowed higher boost pressure, with the emergency power rating jumping from 1350 horsepower to 1500. Boost limits, however, depend on fuel octane, and the engine is designed to run on 100 octane avgas. They can be run on 91 octane fuel, but with the penalty of a maximum boost pressure being reduced. Timing, however, can be left alone. To run the engines on 87 octane gas, both timing and boost have to be reduced, which obviously reduces power output by quite a bit. Total production was something around 12,000 units, so it was a lot more profitable for Packard than the A series had been. The final 5M unit has an aftercooler or intercooler integrated into the intake manifold, although I'm not sure if that was exploited to get more power or as an improvement to reliability. The last running examples of this type of engine are installed in the Higgins-built PT658, which is located in Portland, Oregon. Here is a bit of video which features a Packard V-12 marine engine running in a garage somewhere.
Oh, the monkeys have no tails.